Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1183, indicates a communication failure between the gauge control module and the electric power steering EPS control unit. This issue can affect the vehicle's instrumentation, particularly the tachometer, which displays engine RPM. An open communication line can lead to erroneous readings or complete failure of the tachometer. The gauge control module is usually located on the instrument panel, while the EPS control unit is typically situated beneath the dashboard. The presence of this DTC suggests that the necessary signals between these two components are not being properly transmitted. It's crucial to address this problem promptly to ensure accurate vehicle performance monitoring. The gauge control module, also known as the tachometer, is responsible for relaying engine RPM information. It interprets signals from the engine and displays them to the driver, playing a critical role in vehicle operation. The EPS control unit manages the electric power steering functions and requires communication with the gauge control module to relay information adequately. Proper placement of these components is essential. The gauge control module is generally located in the instrument cluster on the dashboard, while the EPS control unit is usually found beneath the steering column. When they fail to communicate, drivers may notice issues with steering feedback and gauge readings, which can impede driving safety and comfort. Several factors could contribute to the B1183 DTC. Firstly, a faulty gauge control module could be the root cause. This module could have internal failures preventing it from sending or receiving data. Secondly, the EPS control unit may itself be defective, disrupting the communication line. Lastly, wiring issues, such as broken wires or poor connections, can hinder signal transmission between the two components. It is essential to investigate and eliminate each of these possibilities systematically to diagnose the issue accurately. A thorough examination of the associated wiring and connectors is critical, as these are common culprits in communication failures. When DTC B1183 is present, several symptoms may manifest in the vehicle's operation. One of the primary indicators is a tachometer that fails to function, providing no engine RPM readings to the driver. Additionally, the EPS indicator light may remain illuminated on the dashboard, signaling potential issues with the electric power steering system. This illumination suggests that the EPS system is not operating correctly, which can lead to steering difficulties. A driver might also experience non-responsiveness or sluggishness in steering, especially at lower speeds, indicating a need for immediate attention. These symptoms collectively underline the importance of diagnosing and remedying the communication failure for safe vehicle operation. Begin by using the Honda Diagnostic System HDS to clear any existing diagnostic trouble codes. The HDS is a sophisticated tool that allows technicians to interface with the vehicle's onboard diagnostic system, ensuring all error codes are reset. This step is crucial as it clears old codes that might cause confusion during troubleshooting. It helps in starting fresh to determine if the B1183 error is persistent or an intermittent issue. After clearing, it's essential to turn the ignition switch to the lock 0 position and then back on II to reboot the system. This prepares the control units to communicate correctly and accurately log any new DTCs that may appear. Next, turn the ignition switch to the lock position and then immediately return it to the on position. This action is important as it reinitializes the vehicle's electronic systems and allows all components, including the gauge control module and the EPS control unit, to establish communication. Waiting for at least 6 seconds before proceeding gives the systems enough time to engage and reset. This step is vital in preparing the vehicle's computers to generate fresh diagnostic data for analysis. It sets the groundwork for the succeeding diagnostic steps and clarifies whether the DTC B1183 reappears, indicating a persistent issue. After setting the ignition as instructed, check for diagnostic trouble codes using the HDS again. This act allows technicians to confirm whether DTC B1183 has reappeared, indicating ongoing issues. If B1183 is listed, it confirms that there's still a problem with communication between the gauge control module and the EPS control unit. If no codes, could signal an intermittent failure where connections may have temporarily been compromised. In cases where the issue isn't persistent, it becomes crucial to inspect connections and wiring closely to find loose or corroded parts that could cause sporadic failures, ensuring comprehensive diagnostics. At this juncture, continue checking for any additional DTCs with the HDS. If DTCs B1168, B1169, B1178, and B1187 are indicated simultaneously alongside B1183, they imply that there may be a deeper underlying problem that needs attention. Specifically, B1178 must then be addressed as the next step in the troubleshooting process. If none of these additional codes appear, it indicates that the issue might be isolated to the communication failure with the EPS control unit. This knowledge can streamline the diagnostic process, allowing technicians to focus efforts on the specific areas that require repair or further inspection to restore communication integrity. Proceed to check for any electric power steering EPS diagnostic trouble codes using the HDS. This step aids in identifying if other issues with the EPS system exist and could be contributing to the problem at hand. If codes are present, each must be addressed through the specific troubleshooting procedures designed for that code, allowing for a thorough and methodical approach to repair. If no codes are present, it indicates that the EPS unit might be functioning properly on its own, but still not communicating effectively with the gauge control module. Understanding the state of the EPS gives valuable insight into the next steps needed in the diagnostic process. Next, turn the ignition switch back to the lock 0 position. This procedure is important as it cuts power to the vehicle's electrical systems, facilitating safe disconnection of components for inspection. It is a critical safety protocol when working with the vehicle's electrical units, as it prevents any electrical shorts or faults during the examination process. After ensuring the ignition is in the lock position, further disconnection of the gauge control module and EPS control unit can proceed safely. Maintaining proper procedures during these steps helps in preventing unintended damage and ensuring technician safety throughout the troubleshooting process. Following disconnection of the ignition, proceed to disconnect the gauge control module's 36P connector. This connector houses several important wires that facilitate communication between the module and the EPS control unit. By disconnecting it, you are isolating the gauge control module to examine its functionality directly. Proper disconnecting techniques should be employed to avoid damaging any pins or connectors. This step also prepares the way for testing continuity in the further steps ahead in the diagnostic process. It's vital to ensure that connections are not damaged, as they will have to be reconnected later, maintaining the integrity of the system. Next, disconnect the EPS control unit's 28P connector. This action is significant as it takes the EPS control unit offline, allowing for the measurement of continuity and other assessments in the subsequent steps. Similar to the previous step, be careful not to damage the pins or the connector when removing it. This disconnection enables a focused examination of communication lines between the gauge control module and the EPS control unit. By isolating these components, You streamline the diagnostic process and focus specifically on the potential points of failure. Maintaining the integrity of the connectors will be crucial for ensuring effective results in later steps. After disconnecting both the gauge control module and EPS control unit, check the continuity between their respective connectors. Use a multimeter to test continuity between gauge control modules 36P connector terminals number 1 and number 19, with EPS control units 28P connector terminals number 1 and number 15. This step is critical as it verifies whether there is an open circuit preventing communication. A lack of continuity suggests an open in the wiring between these two components, which must be repaired. If continuity exists, it indicates the wiring is intact, and the next step would lead to substituting the EPS control unit to check for faults. This process emphasizes the need for thorough checks on wiring before concluding the precise source of the communication failure. Upon performing the continuity test, evaluate the results closely. If continuity is confirmed between the specified terminals, it indicates that the communication line is intact. Thus, the next logical step is to substitute a known good EPS control unit and recheck for DTCs. If replacing the EPS control unit resolves the communication issue, it confirms the original unit was defective and needs replacement. However, if the DTC remains present, the focus should shift to replacing the gauge control module, as it may itself be faulty. This step highlights the importance of systematic testing and replacement, as it helps pinpoint the precise issue affecting the vehicle's communication network. As a final step in the repair process, recheck the diagnostic trouble codes using the HDS. This verification process ensures that the corrective actions taken have resolved the original communication issue effectively. If DTC B1183 is no longer present, it signifies that the necessary repairs were successful and the vehicle systems are communicating correctly. Validation checks are pivotal in confirming the reliability of the fix before concluding the repair service. Proper documentation of the DTC status is essential for future reference and for assisting any subsequent investigations if similar issues arise. Conducting a thorough follow-up ensures the highest standard of repair quality. To prevent future occurrences of DTC B1183 and communication failures, regular inspections of electrical connections should be conducted. This maintenance task is crucial in identifying and addressing any loose, corroded, or damaged connectors before they lead to serious issues. Keeping wiring intact and in good condition enhances the stability of communication between important electronic components. Additionally, ensuring that connectors are secure can help in avoiding future intermittent failures. Regular checks and preventive measures not only improve the vehicle's performance, but also extend the lifespan of electronic components within the vehicle. Establishing a routine to examine these aspects can save time and money in the long run. In summary, the DTC B1183 signifies a communication failure between the gauge control module and the EPS control unit. Understanding the roles of these components and how they integrate to provide vehicle functionality is essential for effective troubleshooting. Each step taken in the diagnostic process, from clearing codes to evaluating continuity, plays a vital role in pinpointing the exact issue. Regular preventive maintenance can significantly reduce the risk of future communication problems, enhancing both safety and reliability. By maintaining the electrical connections and components, vehicle owners can mitigate risks and ensure optimal performance in their Honda Civics. Please like and subscribe to the channel. See you next time.